Hi everyone and welcome to CodeFX and Effective Java 3rd edition. I'm Nicolai. I'm in Berlin right now for BetCon. Today, item 1. Consider static factory methods instead of constructors. Or how I like to say it, static factories are awesome. Now, I'm going to assume that you've read the item. If you didn't, you may want to pause and do that now. If you don't own the book, consider buying it with one of the affiliate links down there in the description box. You will also find links to a GitHub repo with the code snippets and a Twitter poll I made about this. With all of that said, let's get it on! So, why even consider static factory methods? What's the deal with constructors? Why not use them all the way? And there are actually 3 reasons. The first one is, a constructor call is always new type. So there's no way to give it a more suitable name if you want to. The second one is that you always get a new instance. There's no way to, for example, cache an instance if you need it. And the third one is that you always get an instance of that type that you call new on. There is no way to return a more suitable subtype even if you want to. So these 3 things, a forced name, a forced instance and a forced type, are something that static factory methods allow you to get over. Before we start, let's make sure that we know exactly what a static factory method is. It's, as the name indicates, it's a static method, and because it's a factory for a point, it returns the point, and then it takes the parameters, which are usually the same or very similar to the constructor arguments. The first property of a constructor is that it can have a name. It's always new type. The same is not true for static factory methods, of course. So point has a static factory method of x, y, and then you pass 2 integers. And unlike with a constructor, you can easily tell that the 2 integers are most likely the x and y coordinate. Rectangle has, it's even more pronounced with a rectangle because it has 2 static factory methods. The first one, from lower left to upper right, spans this rectangle, and the other one from upper left to lower right, that's really hard to flip these things, from upper left to lower right. So you have 2 ways to span a rectangle. You have 2 static factory methods for that, but you couldn't have 2 constructors for that because they would collide. More importantly though, even if you settle on one of these constructors, you still couldn't tell which way it is because you would have to pass it 2 points either way. With static factory methods, it's really easy to tell which way you want to construct a rectangle. The second aspect of a constructor is that you will always get a new instance. So the control over instance creation is in the class calling the constructor. It's not in the class that has the constructor. And Joshua Bloch calls this instance control. That means that point of xy, for example, can decide what to return. It doesn't always have to return a new instance. In this case, it checks whether x and y are 0, and if so, it returns always the same instance, the origin instance, which makes sense if you assume that the system will use a lot of will use the 0,0 point a lot. In this case, all the 0,0 points in the system are the same. And this is very similar to what optional does. Optional has a static final field empty, which is an empty optional. And if you have a look at the empty method, you will see that it always returns the same instance. So this would not be possible with a constructor. You would call new optional and don't give it a value, and you always get a new optional instance. This way, you always get the same instance, so in the running system, all the optional instances will actually be the same, which helps save memory. We can do even more fancy stuff. So this point class also has a cache, and it takes an x and y coordinate and maps that to an existing point. And in the constructor, we decide if we are in the 20 by 20 square around the origin, that we always return the same point instances. This is very similar to how Java does integer caching. So there's an integer cache for the first, I think, 100 integers. So you will always get, if your integer value off, you always get the same instance back. You could do something totally different here, of course. You could maybe just cache the first or the last 100 points that you created and always hand out the same instances there. But the idea is the same. The control over which instance to return lies within the point class and not within the calling code. Now, there are 2 things that you should really do, that really look out for when you do this. First of all, these classes should usually be immutable, because if I give you the origin and then you increase the x coordinate, then it's not the origin anymore, right? If I then hand out the 1, 0 point to all the people asking for the origin for 0, 0, then that's surely going to screw with the program. Likewise for the other points that are cached. So if you return mutable instances, you should be really sure that you're always going to, that the program is going to be correct. And the other thing is, make sure that if you write a method contract like this one, that you stress that you're not giving a new instance. Don't say returns a new instance. People might lock on that instance, not being aware that it is shared between different between different parts of the system. So make sure that you return an instance with the specified coordinates or the specified values and parameters in general, and maybe even add, it's not necessarily a new instance, just so users know what they're doing. Oh, one thing I almost forgot about instance control. Since Java 8, there's a concept of value-based classes, which are precursor to value types that Project Valhalla will bring to Java in the far future. If what I just said doesn't make a whole lot of sense to you, don't worry. I'll leave a link to an explanatory blog post in the description box. Now, with value-based classes, you're not supposed to make any assumptions about having any concrete instance. And which better way to promote that idea than to forbid public constructors and only settle on static factory methods, which is exactly the rule for value-based classes. No constructors, only static factory methods. And now you know where there is no new optional, but an optional of nullable or off or empty. All static factory methods, as you know by now. The third property of a constructor is that you always get an instance of the specific type that you call new for. In Effective Java, Joshua Bloch shows us 3 ways how static factories help you get around that. And similar to what he called instance control, I want to summarize them under the term type control, because the static factory method actually has control of which type it returns. A great example for this is list. The list interface in Java 9 got the methods off, and you can pass it 0, 1 or more parameters, and then you get a list of, an immutable list actually, of 0, 1 with 0, 1 or more elements. Now, if you call off with no parameters, you actually get an instance of a list 0 type. Beyond that, you actually always get the same instance because all empty lists are equal. If you call with 1 parameter, you get the instance of the list 1 type with just the 1 parameter you passed it as an element, which means it's a different type that you get back. And the only reason that you can do this is because it's a static factory method and not a constructor, because if it were a constructor, again, it could not exert control over which type it returns. The rectangle class actually does something similar. In the static factory method, it checks whether you want to create just any rectangle or actually a square where all edges have the same length. If it is actually a square that you want to create, it returns a new square. There are a variety of reasons why you want to do that. One thing you can do with this, if you want to reduce your API surface, you can actually make square non-public. So that means that even if you return various types, it doesn't mean that these types have to be public. If you expect your users to call new on them, then they would have to be public though. So this helps you reduce the surface of your API, which increases maintainability. If you go with static factory methods, you have 3 places where you can put them. The first one is you put them on one of the classes that you want to instantiate. The second one is you put them on a dedicated helper class, like the collections class in the JDK. And the third one is you put them on a related interface, like the list.off methods. I just want to add to that discussion that from my own code, I find it weird if the interface knows its own implementations. So I usually go with the other 2 options. In software development, unless you're at a conference, you rarely get free lunch. And so static factory methods do have a couple downsides. One of them is that these methods are harder to discover than constructors. So let's have a look at the Java doc for ArrayList. You will see that there is actually a specific block summarizing just the constructors. And static factory methods, on the other hand, are somewhere mixed in the regular method summary. Now, ArrayList doesn't have one, so it doesn't have a static factory method, but optional has. And so accordingly, you can see, oh, did you know about that search bar? That's awesome on Java 9. Anyway, optional does not have a constructor summary because there are no publicly available constructors. And the static factory methods are just mixed in somewhere. If you go to the static methods block, then with optional you're lucky because there are no other static methods. If there would be, then they would be a little bit harder to find. So it's important to help you users of your code find these static factory methods. The first thing you should do is you should have a block of comment of Java doc on every class explaining what the class does, and in this case also explaining which methods are there to create it. Then Josh mentions a couple of common method name prefixes like of or from that you might want to use when creating these methods. Maybe create there something that is common and that users might be looking for. And finally, and that I think is maybe the most crucial point, is you should not have publicly accessible constructors if you can help it. Because if users find a public constructor, they are unlikely to also go looking for factory methods that might be easier to use. They would instead use the constructor. So my advice is make the constructor as inaccessible as possible.
So, how inaccessible is as inaccessible as possible? If you look at the point class, you'll see that I made it private, that I made the constructor private. If you have a look at the rectangle class, you'll see that the constructor is protected. Why the difference? Well, if you make the constructor private, and I recommend starting out that way, then you get, of course, the least visibility. But then also nobody can extend that class because the class extending point has to call point constructor. So if the extension is involved, if you assume that somebody might extend that class, the question is, who is that? If that's a colleague of yours working in the same code base or even yourself, then I would still go with private initially because you can go to protected any day you want without much fuss. If on the other hand you ship code to a customer or to a user, and they may want to extend the class, and you prepared the class for that, then you should really make the constructor protected from the get-go.
Just a quick note for those people using IntelliJ, although I assume that Eclipse and NetBeans have similar facilities, if you start out with a constructor and then later decide you need a static factory method, then please don't do that manually. So let's have a look at point. I made the constructor public so I can use it here. And let's say later I decide I want to make that constructor, I want to replace that constructor with a static factory method. Then I can just go to the refactor menu and then, see, presentation mode, you can't see it here. Let's see, I'm sure if I scroll and then refactor, or you just, know the shortcuts, which I think is Control-Shift-Alt-T. Yes. Replace constructor with factory method. There you have it. Let's do that. Name it whatever you want. And now three things happened. The first one is the constructor was made private. So apparently IntelliJ developers think that it's a good default. Also, they created the method createPoint, which does the obvious thing. It takes the same parameters as the constructor and calls that constructor. Those two are trivial. The most important aspect is they also changed all call sites. We can see that here, that the factory method we already had now calls the new one. But much more importantly, is this class. This used to be new point, and now it's point.createPoint. So all the call sites, if you have control over these call sites, they will all get updated in an instant. So please don't do this manually.
One thing Josh mentions is that static factory methods are unrelated to the factory patterns. And I know this might cause some confusion, so I want to go into that. To that end, I created a shape interface which does nothing useful at all, but assume it would do something useful. And then I also create a shape factory interface, which has the single task to create a shape. Now, since Java 8, you might want to use a supplier for this, but bear with me. There's also implementation of this, the growing rectangle factory, which takes 2 points and creates a rectangle and always moves that point further out. But the details don't matter. What matters is that it implements the interface. Now, this is a canonical implementation of the abstract factory pattern. You have an interface, the shape. You have a factory interface that creates these things. And now we have an implementation of the interface. In this case, a growing rectangle factory, and returns instances down here that extend shape. So far, so good. Now, the point is, we still use a static factory to create the rectangle. We could just as well use a constructor though. So the fact that we use the abstract factory pattern is totally unrelated to the fact that we use static factory methods. We might just as well use constructors. And the same is true if you use the factory method pattern. Again, doesn't matter whether you use abstract factories or not.
In summary, static factory methods, which are totally unrelated to the factory patterns, allow you to go around the three limitations of a constructor. You can choose a name, you have total control over the instances that you return, and you have total control over the types that you return. Now, my recommendation is to start out with a constructor and then refactor to static factory methods as you need them. If you do that, make sure to make use of your IDE's tools and don't do it manually. If you have a static factory method, I think the constructor should be private or maybe protected if somebody is going to extend that class. Also, to make sure that your users can find the class, mention them, find the static factory methods, mention them in the class's Java doc, and give them common names like of or from. Now, if you like that video, go down to the description box and check out the links to the GitHub repo and the Twitter poll. And you can go to courses.codefx.org where I publish more videos like this. Finally, tell everybody about it, your friends, your colleagues, your mom and dad, your pets, everybody. Bye. To the factory patterns that you might know from the Game of Thrones book, right?